totally don't mind that you're in the other seats. Just don't give me a reason to make you move you. Don't give me a reason that I have to move you, I should say. Okay? I have my calculator open just because you guys should have your calculator out. Remember, over half the test is with the calculator, so the more we know how to use it, the better. I'm getting out of whatever extra stuff I was doing. We're going to be using this button a lot today because where we ended yesterday was with this example. And technically there's like a page that, I think it might be the next page. It says something like, how could you check? I put it out of order. Yeah, how could you check? I put it out of order just because, I don't know. I don't know if you necessarily need to take notes on this. Like you could multiply the matrix of the example we did yesterday one way or the other. And if it is a true inverse, which it is, we solved it, we got it right. If it is a true inverse, what should happen with that multiplication is that it does go back to the identity. So -3, -4, 1, 1, whichever side you multiply it on totally undoes the matrix, which is great. But there's another way to check it, and the other way to check it is with your calculator. Can you guys go ahead and throw in the original matrix, so 1, 4, -1, -3. And I want you to look for where or how we could find an inverse of a matrix, because it's going to really help us if we're allowed to use our calculator sometimes on the test. So we're throwing into our edit the example that we had yesterday, which is just like a 2x2. My question is, once you have this matrix put in, how can you use your calculator to help you check? Or, even better yet, if you're allowed to use your calculator, where in your calculator finds the inverse for you? It's not in that edit, because that's where we make them. It's not in that names, because that's where we find the A, find the B, find the C. But this math menu had RREF. Does anybody see anything in there that looks like an inverse? Ooh, those look like 8.1 row operations. Huh. I think it'd be way easier to do by hand than to try to figure out in your calculator, though. Anything look like inverse? Not that I know of. Huh? You could try. But no. I actually don't know what that one does. I'm not sure I've ever actually done that one. But you wouldn't want to do that here anyway. You would actually want to do that from the home screen. That's one of those that doesn't just automatically take it out. What does that do? Just kidding. Didn't like it. I'm not sure what identity does. Augment has to do with doubly augmenting one matrix with another, like putting them together. That's what augment would do. I don't know if we want to put this with something else, though. We want to find its inverse. Was there a meaning to the 10 to the power of being above the log, or the e to the being above the ln? Or the square root being above the squared? So what's the matrix above? Okay, which, if you do it with a number, we already saw that, I think. I think I did this at the beginning of the chapter, that little -1, but no, it's a reciprocal. Or like, oh, hey, what's 1 over 3? 1/3. Or what's 1 over 6? Oh, that's going to be 0.1666666. Okay. But what happens when you do it with a matrix? Is it still a reciprocal? So the cool thing is, where the matrix menu is, second x to the -1, that x to the -1 also has a matrix meaning. And that's what's so awkward about it. What is this button? The reciprocal button. Yes, if you're dealing with numbers. What is this button? The inverse button when you're dealing with matrices. Oh, even the calculator doesn't know how to use the -1 notation, right? But how is that snazzy for us? Well, did you guys get it to work? We just have to use that -1 button. It will solve for the inverse for us. Of any size, 2x2, 3x3, 4x4. Did you put in your correct matrix, or did you do it of the right one? Go double check. 1, 4, negative 1, negative 3. If you put a negative in the wrong spot, or if you don't put a negative in the right spot, one little change can mess everything up. Make sure you have the right name. Did it work now? Got it. Okay, so now that we know how to use the calculator to find the inverse, that's awesome for the calculator portion of the test. And actually, like, seriously, it's really awesome for the calculator portion. We just have to get back to this whole, we saw a pattern yesterday, and I said it only sometimes worked. We saw a pattern yesterday, I said that it only sometimes works. So there is a little cool formula coming. It's going to be awesome for 2x2s, which is a bummer, because we have bigger ones coming. So before I show you the formula that only works for a 2x2, like the thumb trick that only works for the easy partial fractions, I'm going to show you the longer one, but also the more general way, because remember, in math, a certain procedure is only as good as it can be generalized. This one, the pattern that you saw yesterday, or the pattern that I used of switching an opposite to opposite, only sometimes works for 2x2s, and always works in a bigger formula for 2x2s, but doesn't work for 3x3s, or 4x4s, or 5x5s. Bummer, but this way does. Okay, so what's the other way of solving? Without the trick, without this formula, because it only works for 2x2s. The other way of solving doesn't involve an A and B and C and D, because if you made it bigger, that would be awful. It wouldn't work, it would just be horrendous. A, B, and C, D, E, and F, G, and H, and I, and you would have 3 different systems of 3 variables. It would be a mess. So a much easier way is just to use your row reducing skills from section 8.1. And augment, ooh, there you go, Nathan. Augment this guy with an identity matrix. The same row operations that undo this matrix to become the identity will build its inverse. The undoing of one will be the building of the other, which we could do some crazy marvel, something with that too. But if we can undo, if we can break down, if we can tear apart, if we can legally get this guy to his identity, if we can undo one, we will have built the other, because row operations go all the way across. What do I mean? Well, why am I can't do that yet. I'll do it next. Why am I putting a 1/4? What am I trying to do? I'm trying to get 1 in the corner. I'm trying to do my 8.1 system, so I'm doing 1/4. I'm multiplying by the reciprocal to get mine, but I have to do it all the way across. All right, Nathaniel, don't make me steal your calculator. I wouldn't steal it. I would just confiscate it. But that's not any better. Turn around in your seat. You can put it on your desk. Just don't distract me. If you choose not to pay attention, that is your choice. You could be staring at me with your notes open and be doing the exact same thing in your head. So every day is a choice. 1/4, R1. Divide by, divide by, divide by, divide by. I have my 1, awesome. Am I done? No, but I'm close. After I get a 1, what do I do? Yep, so 3R1 plus R2. Oh, but that's not there, that's for the next step, right? Why am I doing that? Well, because I need to get my 0. I'm literally using my 8.1 skills. All that's weird, all that's different is I was given a little square matrix to begin with. I augmented it with an identity, but now I'm just using those same 8.1 skills. So mental mathers, what do I have for the first one? Next one? Next one? Where'd you go? 3 times 1 minus 3, 3 times negative 1/4 plus 4/4, 3 times 1/4 plus 0, and 3 times 0 plus 1. Come on. Gotta be sharp. My non-mental mathers, we could have gone off to the side, right? Yeah, some of you guys are starting to go to the next one, which you would multiply the bottom by 4. But just a quick reminder, my non-mental mathers, so no stress. Just because you don't mental math doesn't mean that you can't do it. Have to think about it a little differently. You would multiply 3 times every entry on the top, which would give you 3, negative 3/4, 3/4, 0. And then you would pull out that row 2 and everybody that's there. easy as just adding down. You would get the exact same thing. To be honest, you would probably have a higher percentage rate of getting it right than those of us that do it with mental math. Nathan, when you multiply by 4, what did you get in that bottom line?
0, 1, 3, and then 4.
There you go. You multiply by the reciprocal, which is 4 over 1. So 4 times 0, 4 times 1, 4 times 3, 4 is 4 times 1. And now I'm almost all the way there, and my inverse has almost completely been built. But what's the last thing I need to do? Multiply row 2 by 1/4 and add to row 1. So 1/4 times 0 plus 1, 1/4 minus 1/4, 3/4 plus 1/4, oh. And then 1/4.
1.
Oh yeah. 1/4 times 4 is 1, and 1 plus 0.
You know how we switch this up? Because it's supposed to be -3, -4, 1 now.
Did I lose a negative somewhere? I might have.
When you plug it into the calculator, it should be -3, -4, 1, 1.
Oh no, I'm good. 4 minus 3 is 1, and then flip, and then opposite the opposite. Oh. Nathan, this is a new problem. It's not the same one as the one before. It looks similar. Yeah. It looks similar, but it's a different one. I actually thought it was supposed to be the same for a second too, and I was like, huh? But no, it looks the same. But it's different. Now, seeing that at the very end, we've gotten the original matrix down to his identity, and we have built the inverse. So just like you guys wrote in your notes just a second ago, when you do the RREF, you end with your inverse, and this avoids a whole lot of work. Not that you have to write any of this down, but as far as the next example, and what I'm about to show you before we solve it. Oh, it's not there? Where is he? I don't even give you guys a gross one? Oh, I'm far too nice in the notes. But if I was to, section 8.5, you're going to have to build your own encoding matrix for our coded messages, our cryptograms that we're going to be making. To make yours, you might want to do a 2x2, but you might want to make it crazy and go with a 3x3. If so, as your encoder, we are only able to encode messages in a way that the code can be broken and they can be undone or decoded. You're only allowed to use matrices whose inverses exist. A matrix will take something that you have and jumble it all up. An inverse matrix will undo all of that and take it back. But that only works if a matrix has an inverse. And so, if I were to give you guys this one, it totally looks like it would have an inverse. Why wouldn't it? I don't know. But if you were to have to solve it, to find the inverse itself, we could multiply by. What I'm saying is we could use that method from yesterday. But if we did, we would have a 1A2D3G. We would have 3 different ADGs and have to solve that. We would have 3 different BCHs and have to solve that. We'd have 3 different CFIs and have to solve that. That would be a mess. It's not impossible. It's just gross. This way says, no big deal. It's not going to be the best thing in the world. But at the same time, it's not going to be near as bad as that method would have been. In that, we could just do hey, we know what we want it to be. You guys have done something about this bad in section 8.1. In that, okay, fine. Whatever. I have a 1 get zeros, I have a 1 get zeros, I have a 1 get zeros. It would take a few steps, but not too bad. Did you try to do the inverse?
No, I just plugged it in like that into the calculator and then did reverse production.
Oh, alright, yeah. How'd it go?
It's complicated.
Yeah. Does this go to the identity? Close, but not all the way, yeah? This one actually has no possible inverse. Now, how did I know that? Well, A, I tried to use it for my code the other day, and I was like, oh, bummer, and I figured out it didn't. But then B, there is this other characteristic without just plugging it in. Nathan did this and went ahead and put the identity, and then he tried to do RREF. The calculator can do that for you. There actually is this snazzy thing called a determinant. There's a snazzy thing called a determinant. You guys actually might have seen this in your calculator a second ago, because some of you guys were trying to find that inverse thing. Can you look in the second matrix and go over and see DET? Nathan, since you, well, wait a minute, you have this extra part too, right? Oh, never mind. Get rid of that extra part, and then I want you to find DET of this guy and tell me what it is. But as you do that, everybody else, let's figure out who a DET is or a determinant is of not algebra 1. You guys don't want to go back there. Let's talk about a DET of a 2 by 2. Let's talk about a DET, a determinant of a 2 by 2. Now, in case you guys are like, what about the rest of them? Don't worry, section 8.4 is all about determinants. 0. Anytime the determinant is 0, a square matrix has no inverse. AKA is singular. Alright, I tried. But we're still distracted. I'm not going to delete it. I'm not going to erase it. Oh, actually, that's what the car used to try. But, okay, DET. It's a little jagged. Keep working on it, though. Determinant. Okay, how does it work with a 2 by 2? Who's this guy? A11 and A22? Okay, and who's that guy?
A12 and A21.
So if you really wanted to, could you make a little formula out of it and be like, hey, A11, A2, or B22, A12, and B12? If you really wanted to, but what's a better way? Just think it's the main what? Oh, come on, I've used this word lots of times. Main? Diagonal. I used it with the identity matrix. It's the main diagonal of ones, yeah? It's the main minus the opposite. It's the main diagonal minus the opposite diagonal. Main, multiply, opposite, multiply. Hey, row, multiply, column, multiply all that. You have to match up. Ooh, you're kind of matching these guys up too. Isn't it sort of like a dot product, but with a minus in between? Sort of. Not quite as nice as the matrix multiplication, but sort of. Sort of, kind of. You guys saw that there was a pattern in a 2 by 2 of this switching action. AD becomes DA, and opposite the opposite, also true. However, there's actually this much bigger formula, and it's not much bigger, but it is pretty important. The question is, why didn't you see that fraction in front of what we did just a moment ago in those two? Well, we did one of them a moment ago. The other one we did yesterday. If we were to do this guy, who is the determinant of this dude? The determinant is main. What's main? 4 times 1, yeah. Minus, what's the opposite? 3. What was the determinant? Okay, is 1 over 1 going to mess up my pattern of switch and opposite, the opposite? No. What about that other guy that we saw? Who is this one? Yeah. What's the main? Oh man, this whole like writing DET thing is annoying. I hope there's a shortcut notation for that. -3, good. Minus. What's the opposite? -4. So what's -3 minus -4? -3 plus 4? 1. Oh, that's why it didn't mess up. That's why it was switch the main and opposite the opposite. Hey, was there another one that we saw yesterday? What about this guy? Let me try to use the shortcut notation. Ooh, it's absolute value like magnitude of a complex number. Main minus opposite? Okay, whenever the determinant is 1, you will see the pattern of, check it, let's come back to our formula, wherever it is. You will see the pattern when finding an inverse of a 2 by 2 of switching the main, switching the location of the main, and opposite the opposite. But if the determinant is anything other than 1, you're going to see a big difference because then it's going to be 1 over something else times, okay, let's go for it. But do you also see why I had Nathan check that inverse because it wasn't working out when he tried to augment it with the identity and asked him what the determinant was. Whenever the determinant of matrix A is 0, what's going to happen when you try to plug it into this formula? Yeah, it's not going to work. Therefore, it's not going to be invertible because the inverse won't exist. That means that it's going to be what we call singular, and that's what we were worried about. What we were looking for yesterday when we were like, wait a minute, non-square never work. No inverse is always singular. But what about those square guys? They can be singular too. It all comes down to their determinant. And so you guys see that class is coming to an end, but check it. How much do we have to do tomorrow? A couple inverses using the little baby formula, and then maybe, that's just like using a calculator. We already know how to use our calculator. Let's get rid of that. We're done. And then section 8.4 said, let's go play with more determinants. So guys, the people that were gone yesterday, we're kind of slowing down for them, but barely. We'll do some examples of inverses tomorrow. But then you guys, you should already be able to jump into section 8.4 tomorrow, because that's where we're going the second half of class. Have